Hello guys, in this part we will see the variation of the characteristic impedance for a certain lossless microstrip line with the width of the line and the thickness of the substrate and the frequency of the applied electrical signal. Okay, so this is the impedance versus the frequency, or impedance versus the strip width. Okay, and also we could see the permittivity, the variation of the effective permittivity with the frequency or with the width. Okay, let's start with the impedance versus frequency. That's mean the applied frequency, the applied of the electromagnetic wave frequencies. Okay, so here we have microstrip with the 1 millimeter width and 1 millimeter substrate height, sorry, and 1 gigahertz frequency of the applied electrical signal, and the dielectric permittivity is 9.8. So this is the physics dielectric constant, physics permittivity. So when this electromagnetic wave or electrical signal is applied through this microstrip, the substrate will have effective dielectric material, and we know how we calculate this effective permittivity or effective dielectric constant. So let's go back. So here we have, as we said, 1 millimeter width, 1 millimeter height, 1 gigahertz frequency. So the Z node, the characteristic impedance, it's about 49, little bit smaller than 49, sorry. So if we increase the width, we could see the impedance will be decreased. Okay, so now it's about 34. Okay, when we have 1.9 millimeter. Okay, and if we keep increase the width, the impedance is keeping decreasing. Okay, and we saw that and explained that previously here, that the increase of the width will get decreased characteristic impedance. Inversely, sorry, if we, let's back here to 1 millimeter, updated. If we increase the height, we could see the impedance will be increased. Now we have 57 when we have about 1.4 millimeter, and if we keep increasing the height of the substrate, we could see the Z node characteristic impedance is keeping increased. Okay, let's back to 1 millimeter. With the frequency, it's clear. Okay, this is at 1 gigahertz, and when we increase the applied frequency, the Z node is expected to be decreased. Okay, but I think the variation of the characteristic impedance with the frequency is little bit or slower than its variation with width and height. Yes, so that's about the impedance with the frequency. This is the impedance, yeah, same with the width, and the relative permittivity with the frequency. So this is the effective relative permittivity with the frequency. So the effective relative permittivity increased when the applied electromagnetic wave frequency is increased. Okay, and also this is the variation with width of the line, so it's also a little bit or slower from the other parameters. Okay, so now for example, if we change the height of the dielectric material, let's see the height of the dielectric material. So the effective permittivity is very slow, increased slowly when the height is decreased. When we have thin layer, we expect we get higher effective permittivity. When we have thick layer, we expect we have a little bit smaller effective permittivity. Okay, that's about the height of the substrate and the relation between this height of the substrate and the effective relative permittivity. Okay, that's it. Thank you.